Alright, in this video we're going to talk a little bit about program state. Okay, so when we have a simple program, we'll just start out with a user, and we'll say, since we don't know the user's name, we'll call them friend. And user is a variable in our program, and throughout the course of our program, this variable can hold a different value, right? And that may change the behavior of our program, right? But once we end our program, all of that state is lost. All of the variables holding values in our program, they're stored in random access memory. So when we stop the program, they cease to exist for all practical purposes. Okay, so what we want to do is we want some way to save this state in long-term storage, right, on your hard disk or a thumb drive or something like that. So in that way, we'll be executing the program, and at some point, user will change value, and it may change value many times in the program. That's fine, but at some point we might want to save our state, and then that way we can end the program, but then later we can start the program up again, and we will load the state from the file, and we'll resume running right where we left off. Okay, so this idea is, this is a very simple example, about as simple as you can get, but the concept here is we're saving state in long-term storage, right? So basically what we want is make this somewhat interesting. We'll have a loop, and we'll print out a menu of things you can do. Right, so we'll do a little thing like that. And then we can say, we'll use a format string there. And that will allow us to inject other variables and other expressions in here with curly brackets. And we can say user, comma, what would you like to do? Alright, and then we can print an extra line. Then we can give some options, right? So what are some things that we might want to do? Just really simple examples. You can say hello. Right? This isn't a particularly useful program. We can say hello and continue with the program. We can change our name. And then we can exit. And so in this case we'll say goodbye and then exit. Alright, so we got a simple loop. So one of the things we have to do here is collect some user data, right? So this is running in a loop while this is true, so this is just going to keep printing things out right now. So we need some way, some condition in here. At some point we're going to have to break out of the loop. Alright, so let me add a little space here. And we're going to have to get an option, right? So we need some input from the user, and this is going to be the selected option. And so we're going to assume that they can type in a 1, 2, or a 3. Alright, so we can say input select an option by option number. Select an option by option number, there we go. And basically we need to check to see, we have an if-else statement to see what the option we got. So if selected is 1, now remember, anything we get from the input function is going to be a string value, which is why we're checking to see if selected equals the string value of 1 and not the integer version, right? So that's going to be important. It does have to be the string version. So this is pretty simple. We can say if the selected option is 1, print hello and we'll make this a format string so we can inject our username. So in this program, our username is essentially the state, right? All of this other stuff is just kind of a fun way to implement this, right? It's not a particularly useful program, but what we're going to end up having to save is this variable. And right now we don't know what the user's name is, so we've substituted something in, and that's friend. So we just say hello user, and then what we do is we continue through the loop again. Okay, so there's these two special keywords, continue and break, with respect to looping. Okay, continue will stop progressing through the rest of the body of the loop, and then check the condition again and start on the next cycle of the loop. Okay, so for example, if the user has typed in the string character 1, that's say hello and continue with the program. So we say hello, and then continue basically just means we start the loop again. So we're not worried about anything past continue if we go into this if block, right? So another option is if selected is equal to, let's go ahead and check for a goodbye. We'll check for item number 3. Right? And the reason I'm checking for item number 3 is because that lets us use the other keyword, which is break. All right. So here we're going to say print. We have a format string. Goodbye user. All right. Now here we're going to break, and the break keyword is different from the continue keyword. They both stop the current execution of this particular cycle of the loop, right? But continue goes back up and checks the condition again and will try to run the loop if it needs to. Break, however, will not check the condition. So we see the condition here is true, so this is going to be an infinite loop until we get to break. So continue is never going to stop the loop, per se. It will stop one cycle of the loop and go up and try to run it again. Alright, so if selected is 1, we say hello and continue with the program. If we say 3, right, say goodbye and exit. So that means once we break out of this loop, the program is effectively finished, right? Alright, so this break will break us out of the closest loop, right? We only have one loop, so the closest one is this while loop. And then if it breaks out of the loop, we return our indentation level to the global scope all the way on the left, and then we would just print program done, and then the program would be finished. Okay, so that's the break is going to effectively end the program because it'll end the loop. All right, and then the last item we want to add is to change the name. Right, so if we're changing the name, we would also say, let's see, elif selected equals item 2, right? And you could order these however you wanted, really. What we want to do is ask them for what the new username is. Let's say user equals enter a new username. And then as soon as they press enter, user is going to be storing a new value. Right, so these are the 3 allowed options, 1, 2, and 3. And then so if selected is anything else, we will just print out that is an invalid option. And we might make this a format string, but we're going to use single quotes around the format string so we can use double quotes in the string. So selected option selected is not a valid choice. Okay, so again we use the single quotes here to allow us to use the double quotes here. Now we could have just used the escape character / if we wanted to. Right. a couple ways. There's always a few ways to do things, right? So this loop runs. If you enter bad input, it tells you, and then we just run the loop again, right? So that's fine. If you select 1, it prints hello and then runs the loop again. If you select item 3, that says goodbye, and that's what actually ends the program, and we'll see program done. And then if you select 2, then you can enter a new username. Okay, now this is the important one for when we're talking about state. The state of our program. The only important variable as far as saving the state of our program is this user variable. Selected isn't part of the state of our program per se. Technically it is part of the state, but we don't need to save it to start the program back up again. Okay, so we do need some value for user. Otherwise it's just going to start out defaulted to friend. Okay, so it is important to decide what variables are critical for your application to save. What are the things that your users are going to want to keep, and then things that aren't important, like the last thing you selected, the last option, that's probably not important to our users, so we don't need to save that one, right? So there's only 2 potential things that we could save, and we've determined that user is the one that is important. All right, so let's run this. We're in our desktop. We'll say Python 3 state, right? What would you like to do? So let's say hello. It says hello. What would you like to do? Let's change our username and change that to Bob. And then we see that that has changed, and we can go ahead and say hello again. And we see that has changed, right? So our state, our variable has changed, right? And then we can say goodbye, and it says goodbye, and then the program is finished. Okay, so that's exactly what we outlined would happen. But when we run the program again, we're back to our username being friend. Okay, we don't know, the program is not aware of the previous choices we made when we were running the program before. So we need some form of long-term storage to save this, right? And so the simplest way to do that is with a file. All right, so what we want to do here is create a file, and it's a data file, and there are many different formats to data files. We're just storing one thing, so we're just going to call this a DAT file, which is super generic. Doesn't necessarily mean anything in particular. Lots of different programs use DAT files, and they have different formats. Okay, so this is a DAT file, and I'm just going to store in data. So the data I'm going to store in here is the username, right? So when I start the program, I want to check to see if this file exists. Okay, so I'm going to use a special library, import OS, and I'm going to see if os.path.exists. Right, and the path that I'm checking for is our data file. So admin.dat. And if this file does exist, then user is going to get, we need to open up the file and store the contents of the file in our variable user, right? So to open a file, use the common syntax file function open admin.dat. How do you want to open this file? We want to open it for reading, right? And then we will say our user is equal to file.read. Now we want to strip off any white space. There might be a new line character or something in the file. Right, so we'll strip off any white space, and that will be our username. We might want to, if there's multiple lines of text, which there shouldn't be, it might be corrupted though, right? We might want to, we'll do that later. All right, so this should be good enough. So we'll assume that nobody's modifying this text file manually, and it should be in a good format. All right, so we're going to read the data, strip off any white space at the beginning or the end, and store that value in user. All right, and this is only if the file exists. Okay, so right now it does exist and there's nothing inside of it. So we're going to delete this file because our program needs to create it, and it'll only create it and put a value in it, right? So we shouldn't have to, as a program user, we shouldn't have to manually create data files and store files and things, right? The program should do that for us automatically. So the first time we run the program, it should do that, right? So if the file exists, we open it and save the data into the user variable, and then we would close the file. All right, and then otherwise, so if the file path does not exist, right, what we want to do is we have to create it, and we're going to store our current user value in there. Okay, so this is where we are creating the admin.dat file. Okay, so how do we do that? It's very similar. We say file equals open. What are we opening? Admin.dat. And how are we opening it? We're opening it to write. And then we can say file.write. What are we writing? We're writing the variable user into the file. And then file.close. Okay, so the very first time we run this program, this file does not exist, right? So we skip over here to else, and we're going to open the file. This essentially creates the file, and we write whatever's stored in our user variable. So it writes this string data to a file called admin.dat, and then we close the file. All right, so that's effectively all there is to the beginning part, right? This creates our state file, and if the file exists, we'll load in our user variable from it. All right, so we can try this. I will exit. Oh, sorry. 3. All right, and we run the program. And notice as soon as we've run this program, we look over here and this is created and we have friend in there. Now that is because our program first encountered this if statement. Does this file exist? The answer is no, that's a false. So we do not execute this and we go to the else. So we open the file, write in the username and close it. Now we're back to here. So here, this is just our normal program again, and I can say hello, that's fine. I can change the username and change this to Bob, and it changes to Bob, and then I can say exit, and that's fine. Now, when I run the program again, we still have friend, right? So we didn't actually save our state, but what we did do is we set up a file so we can save our state. So the difference is, when does this variable change? That's the thing we have to be aware of. When are we changing this variable? And whenever we're changing this variable, we might want to open up that file and save it, right? So we're changing that variable here. Whenever the user types in option 2, change the username, right? So whenever we get a new user, we might automatically save. Or you could add another option to manually save, right? A lot of programs do things with automatic saving, but some of them don't save until you tell them to save, right? So that's an option. You can do that however you like. It depends on the program. So in this case, we're going to auto-save. So to auto-save, what do I have to do? Well, I'm basically just doing this code, right? I'm opening the file for writing, and I'm writing the new user value, and then I'm closing the file, right? So I could just copy and paste this. Alright, so if I exit this, run the program again, so we start out with friend, let's change our name, and we will change the name to Bob. Alright, what would you like to do? Let's say hello, that works. Let's exit, goodbye Bob. And here we see we have successfully saved our state, and when we ran the program again, it used our old state. Okay, this is about as simple as an example as you can get that actually does something, right? We had a menu and stuff, but this program actually does something and it saves that value. And you can, as you run this program, you can modify that saved state. Okay, so let's say goodbye here. And now I can go away for hours and then run my program again, and it will still have the state that it had previously. So this concept of state is very important. All of your internet applications and services, most programs are going to have some way of saving state, and it could be to some data store of some kind. And a file is the simplest kind of data store. Long-term storage, you just create a file and you store something in it. All right, so that's why we talk about files first. It's the simplest kind of data store you can use to have some sort of state stored when your program is finished. All right, so hopefully that helped you understand what the concept of state. If you've heard that term a lot, it's just the variable values in your program that are important for you to be able to stop the program and then run it again later. Okay, so technically state is all of the program variables, but when you're saving a file, saving a program, you don't need to save all of them. You have to think through which ones are important to save, and you'll have a saving process and a loading process. All right, so here is our loading process. If the file exists, right, we read the data in, so this is loading, and if it does not exist, then we create it. One more thing here, if we do something to our admin.dat, like say we add in some extra data here, this is kind of gonna corrupt our file. Right? So if I run this program again with corrupted data, you see it messes up. Like the program still runs, but this isn't what it should do, right? So what we want to do here is, I can change the user and it will fix itself, right? So I can say, and we see it's fixed itself. The file itself has changed, right? But one of the things I want to do here is make it so that won't happen. So I'm only going to, when I read in the data, I'm going to split the data over any new line characters that exist. And if no new line characters exist, that's fine. There'll just be one item in this list, and then I'm always going to just grab the first item in the list. Okay, so what that's going to do is I can have a lot of different lines of junk in here. If someone manually corrupts this file, then that doesn't matter. I can run python.state and you see it wasn't corrupted, right? Even though the file is corrupted, it just used the first line, whatever's there, and it ignores the rest. And then if I change the name again, it will also auto fix the corrupted file, which is nice. So these are nice behaviors to have when you are considering using a data store. You want to prevent data corruption, and even if the data is corrupt, you want to make sure that the program still works if you can, within reason, right? So we can change the username to Bob and then exit, and we see admin has now been fixed. The file is no longer corrupted. All right, so that's a little video on program state.